In our group was Arthur Brown, myself, Justin Neubauer, Ray Foster, Kevin Raymer, Jose Marrero, Jarvis Monroe, and Jared Skinner.
Executive summary, problems in advertising. In advertising, sometimes it would be very useful to have visual displays to catch the attention of prospective customers. Our solution to that is the 8x8 LED cube, offering dazzling effects that may be programmed, including graphics and moving text.
All right, our road to completion. We brainstormed. We had various project ideas, but ultimately came up with the LED cube. Our inspiration was a YouTube video showcasing a cube. We did a lot of research. The internet provided great sources for our research and design. We did analysis and design. Details and hints were provided from resources where we analyzed them to develop a block diagram and a flowchart. Building. The project involved extensive building of circuitry and physical construction of wiring of the LED cube itself. Troubleshooting. Once the cube was finished, there's extensive troubleshooting that we went through to get this working. And documentation. All diagrams and reports were generated and compiled.
This is our Gantt chart, indicating the tasks that each individual or the entire team has done throughout the course of the project. We brainstormed, we researched the LED cube, we examined videos, we did system analysis, we constructed it, we built the prototype, which required assembly, soldering of the LED layers, and a microcontroller board, as well as a multiplexing board. We did the final assembly. Took us a while, but we managed to get it working, and it's functioning right now. We did testing and troubleshooting, of course, and in terms of documentation, you see the Gantt chart right up there. We got the schematics done, block diagram, flow chart, bill of material, and PowerPoint. This is just a chart indicating the process, starting from December and ending around March.
So the engineering summary, the 8x8 LED cube is built in a way that it could have spectacular lighting in a three-dimensional array. We use it for many applications. For example, store windows, even here at ITT Technical Institute, we're going to put it up in the display to possibly attract newer students further in the future. We have applications as far as fireworks to raindrops to it even says ITT Technical Institute in the LEDs.
Good one.
The effects are programmed by the Arduino Mega 32.
The LED cube is wired in such a way that it uses the X, Y, and Z coordinate system. Each LED uses the X, Y, and Z coordinate system to be selected by the microcontroller. The Arduino Mega 32 is the microcontroller that we used, and that is what is used to program it and to select each different LED faster than I can see. And these, yeah, pretty much. That's it.
Each vertical layer is connected by cathode. So, for example, all of these cathodes are tied together, all of these, and so on. That's connected to one of the ports. It's controlled by transistors to switch faster on and off. Each vertical spike of anodes is tied together, which is addressed by the 8 output latch chips. And those 8 latch chips are controlled by a decoder multiplexer, which we use, again, another port, so 3 ports being used on the controller. And with that, we can address any LED. The latches were very key to kind of extend our reach.
This is a graph just showcasing one spike, one LED in one row. It is 8 LED in one spike going horizontally. And this is just the PV. It selects the row. The port B is selects the row. Port A selects the LED in the row. Port C selects the layer.
This is our block diagram. It's shows your representation of port A going to the latches, port B going to the decoder, multiplexer, and port C going to the transistor bus.
This is the schematic of our controller, and the cathode's connected to transistors to the controller. I believe this up here leads to the other board, which I'm following. Now this is our bank of latches controlled by the decoder multiplexer. There's a connector, LED indicator, and smoothing capacitors from our power in, just to keep everything constant voltage.
This is our flowchart for the Arduino programming that we put. The program will start, and then it will include the library files of string H. It will run the setup program, initialize, and configure the microcontroller. The flowchart on your left will be your subroutine, in which it will slow down the flash, so it will actually be seeable instead of it just doing the entire program and just end. It'll slow it down so you can actually see the visuals that it will light up. You know, the entire loop, it will loop around, so we turn it off. It'll be just a display. It'll go from moving the Z-axis 20 from top to bottom, all the way down to the LED shoot randomly surface on one side, and then it'll just loop again until we turn off the, or we just plug it off.
Any questions?
Ready to see it?
Go ahead, Arthur. Right now, it's running the test.
So fortunately, we had a little bit more debugging to do. You might notice that this layer on top isn't lighting.
Should put like a random little trance music and stuff just so
Right.
it'll fit the music. Without the subroutine, we would not see it. It would just blink at the end.
The hair is cool.
No, this is the instructables.
Oh,
Yes. We only got this working this morning at 6 o'clock this morning, so we still have bugs to work out of this, but the last 2 days have been very intense for us.
It's okay, right? We can just put the entire thing upside down.
We will get it properly working before it goes into the display case.
Sounds cool.
Oh, I like that.
Tetris. No, it's not. Looks like it.
Almost.
Rubik's Cube.
So as you can see, we can do very much anything as far as words and whatnot in the advertising field.
You can program pretty much anything into it. Make like little visuals and stuff.
Now it's just a matter of how big you want it, and you have to add that many more latches to extend the ports.
So you want to use it for LED? You want to use it for like an LED sign?
A 3D,
That's
possibly
an
a
application.
Yeah.
LED sign.
3D.
It's just the effect in zero gravity.
Most of the modern signs are now done like this.
And then it's pretty much, it's, I think it's just that, right?
No. Two more things.
Okay.
Two more things.
We've got two more layers to go through before we start. They're bubbles. It's the bubbles. Got 30,000 bites of code.
Listen here, the lounge going down.
Yeah. 30,000 bites of code.
We'll get through the debugging and it'll work right. It will say ITT Tech coming out at you.
Well, did you guys spend it on
10 weeks.
10 weeks to build, but we did not get the supplies until the 5th week. So, the build took a while. Mr. Smith?
Was it just the class time that you spent to get this done?
Oh, no. I will let you know in the last 48 hours that Arthur and I did not get much sleep. And there was plenty of these gentlemen that came in all week long and spent extensive hours here in the lab.
Dedication, gentlemen.
Tons of soldering.
Yes.
Yeah, you gotta be done for something.
And it's,
Yeah, they're already want to move around.
All right.
Questions? Anybody?
Yes, can I have one of these installed in my living room?
It's gonna cost some money, though. They have a lot of man hours into this.
That's beautiful.
We also use the green LEDs because we researched and found out that that's one of the most sensitive lights to the human eye.
The red ones are substantially cheaper.
Yeah.
But like, you know, like, people are gonna look away, that's not the point.
Good job, fellas.
Thank you.
That's awesome.
That completes our presentation.
You were going to say something? Or?
I said that completes our presentation, I believe.
Anybody
I
have-
just want to make a comment that these guys did this all themselves. As far as this, they put in the time. A lot of times I really help out with things I wasn't able to do as much. You guys did this yourself from scratch. And that's a really, I'm very proud of you guys for being able to do that and get it. I almost didn't know if you were going to do it or not, but you did. It took till 6:30 in the morning.
Right.
Yep, we got that.
That's our persistence and some
Grit.
grit.
Yeah. It's worth it though. It was quite amazing watching you guys play yourself through them all the hours and
Oh, yeah.
the amount of work.
We got to give thanks to Jay for coming over last night.
The secret member of our group right there.
Yes.
Yes, sir.
I wish he was part of the plan, man. You can just watch this right now, yeah.
Stealing the show right now. Like,
It deserves the show.
So how many hours total did you guys say it took?
Oh, man.
Jeez, it's hard.
In soldering alone, probably, I don't even know.
You got at least 30 hours in soldering alone.
In soldering alone.
And just the cube.
Yeah,
That's not the boards or
Can I ask you a
anything.
question? Were there any problems that you encountered?
Yes, there were several problems that we started right from the start.
It took a while to troubleshoot. Luckily, if it wasn't for the resistance, we would have not gotten this.
a lot of times, these are kind of flimsy joints, so they'll come loose. You might even see that there's a few down here that need to be touched up. The wires that come off of it, from the wall to these, everything has to be checked 4 or 5 times.
If not more.
Yeah.
Which we, couple nights stayed up checking.
Mr. Smith?
I got, what does it look like for expandability and marketability? What would you use it for, and how would you use it?
Display names of your, what you're promoting. Just for visual effect alone, there's possibilities since it's 3D. You could just start from the middle and just go around and just make a visual effect from
Think of this as a building block to a much larger visual possibilities.
How about a whole building?
That would take years.
Exactly.
If you walk by a building that's lit up like that, you would stop and gaze and stare.
You may not sleep. Just don't build a house next to it.
Hold up, spend a lot of money on gas, bro.
I'll feel bad for somebody that lives near that, that's for sure.
Do you think you guys would be able to benefit from any nanotechnology using something like that?
Oh, definitely, we can streamline it. Yeah.
Did they have updated boards and stuff with smaller chips?
That's right.
Printed circuit boards. We didn't use any printed circuit boards simply because Reynolds wanted us to do it ourselves. They do have them online, which make it 10 times easier, but
Yeah.
we did it all. Follow schematics.
And we had to change certain things from the schematics just to, condense it.
And what are the capabilities of the possibilities you use in the software that you're using? What source program and how would you, what could you program on there?
It's C code.
There's a lot of different, I saw one video where a guy had his computer hooked up and it had like a swirly on like his video player on his computer and it was streamed directly to the cube.
You can stream it, okay.
Yeah,
Video
you can do all sorts of different stuff.
What about 3D video, something like that, make a figure?
We did see one online that actually had individual people and it moved in 3D. It was very
a
cool.
bunch of LEDs, like it was literally.
It was human size.
Yeah, it was huge, it was really big. Great job.
Thank you.
Thank you.
Can you make a little person on there doing like dances from the 80s and 90s?
It would require a lot of code.
It's possible.
Yes.
Would you like to sit down and write code with us?
Sure. It depends what dance too, like you just can't do a random dance.
How about the cabbage patch?
I don't know what that is, but that sounds good.
You might be able to get the guy to do the sprinkler.
There you go. That's very awesome.
That's 150 pages of code, 30,000 bytes of code. I was running through that right now, 30,000 bytes.
What size Arduino did you use? Yeah, Mega, the Mini?
Used to, no?
Uno? Uno can do that?
So what is that, a 32 kilobyte?
Yeah.
Was it pretty much the whole thing?
We pretty much filled it.
Okay, I was gonna say Mega would do awesomely much more.
I thought the Wisdom magazine we were using.
Nah,
No.
I got an Uno on my back. I'm saying, yeah, like that man's some stories. You go to David,
Let's just leave this here and just have everybody watch it.
Well, we gotta work some bugs out of it, right?
I'm just kidding.
It's actually quite sturdy.
Very stable.
It's very stable.
Oh, yeah.
It's not flimsy at all. It is
Great.
touchable, but
As long as
the
you don't
solders are,
The joints are what you're concerned
yes,
about?
they're very sensitive. So how much pressure you
Over
put
1,000
on
of
it.
them. Over 1,000 just in the queue right there.
Wow, 1,000 solid joints?
1,024.
Oh, that's right.
Do you consider any
Hey, what's that man you up?
500?
Yes, take into account the
1K. Yeah.
support beams too.
Oh, yeah.
24 is 1K.
Well, you have to take in, the support beams were even more solder joints.
Cross members going down every other layer. That's not even touching the blade itself. Yeah.
So what do you think, Don? That would look good in the display case?
Yeah, I think we can get a display case. Look the words at the back.
Oh. Well,
We're not gonna
we'll
do
get
it.
that
Bolt
in
it to
there.
the ceiling.
There it is. That is
Very
awesome.
nice.
It is awesome.
It's going down now.
I think every
We have
time it
to-
goes
We have to
through-
check the wiring. I think we might have them flipped.
That's okay. That's easy. to fix.
With throwing it together in 15 minutes before we came in here to rehearse, it was, we were unable to work all the bugs out of it.
But it's done his job.
Yeah.
Visually.
For real.
Yep, the visual is there.
Double seven of you working on this project?
Yes,
Yeah.
yes.
Tons of work, documentation, soldering.
We had to split the world, so
Yeah.
definitely.
You know, I can see why a project this size, or a project for this undertaking requires so many hands
But
about
it
presentation, soldering.
it had to be
coding.
dedication on both documentation and like the
Exactly.
actual
Yes.
construction in order to make this possible.
Yeah. Believe me, take writing is not that easy.
Bulk of it was soldering, honestly.
What do you think you'll have,
Mostly soldering.
have the bugs worked out?
We can work on it a little bit today,
Over the weekend,
over the weekend.
we still have a class tonight.
Yeah.
We should try to-
Right, so touching it today, probably.
We need to take a step back from this thing for a little bit and get it pushing down.
Just usually.
Yeah. We'll do a couple days of sleep and then get back after it.
Got very juicy on it.
Yeah, maybe we'll have
Oh,
juice at the end.
I should have wrote
Young Skywalker.
dedication to this man right there. You know who you are.
Could you develop that into some kind of toy so somebody could just flip a switch and see different colors or?
As a toy?
We did not go with that LED. I don't think it could be used as a toy, but there are LEDs that actually have 4 different colors, 3 different colors.
Yeah, they have the red, green, blue, red RGB cube, which is
Right.
3 different leads though.
That would have been more solder.
Crazy hard, I think.
For the length of time you had,
Yeah, it would have been a whole different ballgame.
Yeah,
Like,
if we had more time on this project,
real, definitely.
oh,
we would have definitely had
Actually, it's
all
for,
the bugs worked out of
I
this.
got a question. Do you think it's advisable for students to wait till the first week of their senior year for a capstone to start?
No.
I don't believe so. I think that you should be thinking about it in advance, have the idea, and maybe the quarter before, order the parts so that they're here on week 1
But,
of capstone.
but you have to consider that this is a group thing. So like, just because I want to do something doesn't necessarily mean Ray or Arthur or everybody here won't want to do it. So at the end of the day, it's a group effort. So we like, if you know who you're gonna pair up with, discuss it now. Discuss it.
Also, breadboard.
Yeah, breadboard your project before soldering it together.
Oh, yeah. You should.
experience.
It would have been so much simpler.
Yeah, you could have got
Solder
it. You
together.
could have got the layout down too.
We did.
Thank you, sir.
As your usual, is this a moment?
Yes.
Never worked in cold.
Any other questions?
No, we saw that.
Thank you guys for coming, and you guys did
Yeah.
like
Close their presentation.
No one's left, you just stayed here and looked down all night long until the next
Every
day?
house. Every house.
Now, is this did you guys make your own YouTube of this or something? or-
No, we're working on it. We would like to get it working properly before and have it display ITT tech.
What I'll
That
do
would
is I'll
look
take a
good
video,
for
just send me, or you can mail it.
Thank you so much. Working.
On the top of the video.
I'll see you guys
All right.
next week, right?
Awesome. Thank you all for coming.
Yes, thank you.
Thank you.
Great job.
How much did I miss?
Getting the entire presentation.
Thanks for your help today.
Yeah, I actually have I don't see it being a problem coming in next week because it's all, this is the